Hey, hello, Serverless crew. Thank you so much for joining Serverless Office Hours on Twitch, YouTube, and LinkedIn. This is the first time. If this is the first time you're joining, welcome. Let us know where you're chatting from in the chat box. And thanks again for joining. For all of those who have been with us before and you're scratching your head wondering who are we and what are your usual hosts, well, they have left us here to hold the fort for the next hour or so, and hopefully they're enjoying some well-deserved time off the streams. But fear not, we're here to make sure your serverless thirst is quenched in this hot July. I am Giuseppe Battista. I'm a startup architect in the UK and Ireland, and I'll be your host for today. As you may know, the main topic for today is how to build cost-effective generative AI solutions, mainly using serverless architectures. And I'm here with João, who has explored many of the serverless techniques and architectures we're going to show you today. Asia, how is it going? Thank you for joining.
Of course. Always a pleasure to talk to you, Giuseppe.
Yeah, sounds great. Thank you so much. So, can you tell us a bit more about your role and what you do? You're also like a startup architect, right?
That's right. So I'm a startup solutions architect. I work for the startups team that covers Iberia and a little bit of the South France and Italy. I'm also part of the specialist community in AI/ML, and in that sense, we basically cover the whole world, any kind of company from large enterprises to the smallest of startups, and we basically provide guidance
Yeah.
to reach good port and do things effectively.
And I guess that you've been chatting with a lot of customers, especially you've been like dealing with a lot of, I would say probably the whole spectrum of startups from like early stage to Series B, Series C, and I guess you've been exploring this sort of ways to kind of get your hands dirty with generative AI, but without breaking the bank. And so today is going to be, I guess, the focus. So I know you're a prolific author, so I really want to leave the floor to you and guide us through like the tips and tricks that you learned. And folks, I'll be also on the chat, so if you have any questions, I'll be taking out from there. But I guess first item on the menu, I read an interesting article about how to run small language models on Lambda and LangChain. So I would like to introduce the audience to that, maybe.
Yeah, so maybe you can share my screen and then you can kick
Absolutely,
off from
there it
there.
is.
Yeah, so just a little bit of context. Today we're going to cover some of the articles I've been posting on AWS community. If you don't know the platform, it's a very good one. Anyone can publish there, and we strongly encourage you to go to the platform, explore some of the articles. It's not just about GenAI. We also have some things around serverless, as you can see, also custom optimization, DevOps, even some of the bleeding edge services we've been launching since reInvent, like Amazon Q, but there's a lot of things. Okay, so for today, like Giuseppe mentioned, we're going to cover a lot of things. Actually, we can start a little bit about what the small language model is, right,
Yeah,
Giuseppe? Just
sounds good.
giving a little bit of context, and then we'll start exploring some other things.
Yeah,
How
and
does
I'm
that sound?
posting in the chat a link to your profile on community.aws, so you
Ah,
can have a look
thanks.
at those, at all of the links that we're going to cover today.
Yeah, thanks, Giuseppe.
All right.
Um, yeah, so just a little bit on small language models. You probably heard about this moniker. We talk a lot about LLMs or large language models. Up until now, models have been increasing in size, also in the quantity of data they're trained on, among other things. But now we're starting to see also the inverse tendency, right? Right now, they've been exponentially rising in the quantity of data they've been trained on and the number of parameters. There's all this notion around scaling laws. Now we're seeing that we can actually get the same gains from a smaller model. And there's a lot of buffer to the models we've been training so far. And that's really what a small language model is. It's a model that's either small in size, the model artifacts, and that can be for a number of reasons, like less parameters, or the parameters are encoded with a data format that doesn't take so much space, and probably heard of quantization, distillation, all these things that you can do to a model to bring it out to a smaller size, or it can be trained on less data. So that's also an option. My definition, I think it's a good rule of thumb for the serverless community, is that if it's small enough to run on a Lambda function, then it is a small language model. I think it's
Okay, yeah, that's a great
a
one.
good
And
rule of thumb.
if you have a different definition for a small language model, please let us know in the chat. We're super curious to learn from the audience as well. So yeah, so you mentioned small language models. So it's small in terms of parameters. It's small in terms of probably the data set. How about the capabilities? Right? Is there any trade-off that we should be aware of?
Yeah, so in terms of latency, they'll actually be a little bit faster than traditional models. They don't require as much compute. That's actually why you can run them on a Lambda function without using a GPU. Some people also run them locally for their own setup. One of the disadvantages is that we don't really know, depending on the type of technique you're using to reduce the model size, what exactly are the aspects that the model is not going to cover. Okay, there's some things that may be lost when we do this kind of transformation. Okay,
So
but if the
there's
model is small from the get-go, if it's in train and tested, and it should be on par with, at least on some tasks, with the more advanced, bigger models.
and so there's a little bit of not training, but like testing that you have to do basically to understand if it's the right fit for your use case, right? And I think
Always, yeah,
okay,
always. So
sounds
that's
good.
a given.
So probably Lambda is a nice playground where to do this sort of stuff.
Yeah, yeah, that's for sure. So we're talking here about small language models. Are we going to cover near well, in the middle of the session, some techniques for running bigger models? Okay.
Nice, nice.
We'll get that in a second. So basically, the plan for around this blog post and what are you going to do? I'm going to try to do this live. I don't know if this is going to work as I expected, but we'll do the best we can. But basically, the idea is to take a model artifact. Okay, build a container around it. We're going to use AWS SAM. The original post was around just running AWS CLI commands. And we're going to take advantage of two nice features of Lambda. One is response streaming, the other one function URLs.
All right.
These are very nice for chat applications because we don't need to wait for the response. We need to wait for the final token to come in to show the response to the user.
Okay, so basically you are sending the chunks as they come out of the LLM basically to the user.
Yeah,
Is that okay?
that's exactly it. Yes,
So
exactly.
the only like piece of compute that is actually running is a Lambda function. You're not hooking it up to a GPU behind the
Nothing.
scenes. You're not doing
No,
anything magic like that. Okay, sounds good. All
nothing
right.
of the sort. Yes,
So it's
yes.
CPU only, running on Lambda, a small artifact. Well, by the way, where are we getting the artifacts from?
Yeah, so that's a good thing. Yeah, so in the build section, you can actually see. So these are coming from GPT for all,
Mm-hmm.
which has well, I'm not sure where the models are, but if you scroll down, you'll see a list of models in different formats. The models I'm going to use, well, in the original one was Falcon. As you can see, it's Falcon and 4-bit quantize. That's what actually this means, and it's in a ggweb format. So there are specific formats for models that are optimized for inference.
And wait
Uh,
for a second. You mentioned quantization, right? So just wanted to know exactly what that means. So can you give us like just an overview of what does that mean?
yeah, so it's basically taking the parameters of the model. We usually talk about this as just numbers, which are usually encoded in a float line format, float 16, bfloat, and basically encoding that into something that doesn't take as much memory. It can
Okay.
be common formats are 8-bit and 4-bit quantization.
Okay. So basically, instead of have like the long, let's say high precision number, we're trying to like squeeze it down to like a data type that is a bit smaller. So therefore, we'd
Yeah,
actually okay, we're able to run this into like the local CPU RAM instead of like the need of
yeah,
large arrays
that's
of memory.
that's exactly it. So, but the issue with these things is if you quantize them, you may lose some information that was relevant for the model to begin with, and you may not get the same answers. Okay, or at least the same quality of answers. They may be fall in the same ballpark. No, so
Okay.
that's the hope when you bring the size
Okay.
down.
So the main trade-off here is like the probably the accuracy or like the let's say expressivity of the model. I don't even know if that's a word. Apologies. But like the power of expression of the model maybe, or like the factuality. We don't know because that's sort of like a black box to us so far. But yeah, okay. So sorry, I'm sorry to interrupt you, but like this questions I
No,
think
no,
will
no,
be
no. It's just, it's a very interesting topic. Okay.
yeah.
Yeah, but yeah, so what we're basically going to do is to download the model, and then we're going to download also configuration, well, because we're going to use GPT for all. So response streaming is only available for Node.js, and GPT for all is nice enough to provide us with an SDK that we can just use out of the box, and then we can just create the lambda function and just use that.
All right, let's dive in and
Yeah. So, so my idea for today, let's see if you can actually manage this. Let's check this. So the first thing we're going to do is install AWS SAM. Okay, it should be. Let's see if we can do it an easy way. So basically, let's just go into, and then we're going to
I'm
let's.
sorry. If you can make your
Yeah.
fonts just a little bit bigger,
Yeah.
so everyone can
Let's do
see.
it. Yeah, let's just do it. And now we're going to, well, the steps all here. We're just going to unzip this and run the installer.
Okay.
Just
So
run this here.
exactly from scratch. Wow.
Yeah. So very, very, a lot of things that can go wrong. So let's just hope that nothing
That's okay.
goes wrong.
And Chad, by the way, let us know if you have tried to run like small language models, if you have run this sort of tests, understanding a little bit more about the use cases that you are currently trying to bring to production or you have brought to production. Would be super keen to learn more about that. Okay. So right now we're seeing a flash, like
We're
a shell.
deflating the humongous zip that is AWS
Nice.
SAM, and
Okay.
then we can just run the installer. It doesn't take long, and this is just happening because we're buffering the screen. So
Okay.
it's
Okay. Okay.
very.
That makes sense. So in terms of the model that we're gonna choose, like, do you have to download it? Like, how does that work?
Yeah, so actually, this is defined in the code. Okay, so this, if you want to check the original steps and use the original code, it's all here in the main branch. For this one, I prepared the assem branch, and this is one you're going to use. Now, inside I don't know if anyone's used AWS before, but basically, it allows you to create serverless applications in a easy and nice way. And the only thing we need to define is a SAML config and template. And if you go inside the template, we can actually see where the model name is defined. So
Yeah,
inside the Docker, when we're building the container for our serverless function, it's going to download the file and then place it inside.
yeah, and basically you can find this into the sorry, you can find the link to the article that João was showing in the chat box, and I guess you have a link to the repository as well. So if you have it, let me just I'll see if I have it in my notes, or I can have a look.
Yeah. So
So
right now, so we have some installed, and we can check this is true. Okay. And now we're going to clone the project. Oh, okay. Yeah, of course. Let's just update all of this because this is really from scratch.
yeah.
And let's just go for Git. Okay. Okay, maybe, yeah, not T, Y. Okay.
And what is it exactly happening right now?
So we'll have to install. Let's just do this actually. Let's just going to install Git because we need to clone the repo.
Oh wow! So you're starting from very, very, very scratch.
Yeah. So installing Git. Now it's working.
MS. I have.
Yeah. Now we're game. Okay. So we're going to clone our repo. Just go for this. I'm going to zoom in before you tell me to, and just go for our slam the function. And now you're going to check out the SAM branch. Okay, and now all the steps are actually right here. Okay. So basically, in this case, we have to configure the credentials, which I'm going to pull from here. Let's just do that, and we'll just clean the screen. And let's just go for the actual command. So there are 3 commands you're going to run. One is sam build, basically create a container. I'm just going to do that. Yeah, where is it? Why is it? Yeah, of course. Let's just go install Docker.
Oh, wow.
System is always right.
So in the meantime, let me have a look at the, the actual repository, because I wanted to share um, the link as well. By the way, if you have it and you can paste it into the chat, that'd be fantastic. While I try to find it.
Yeah, and let's just reboot this.
So you're using like an EC2 machine somewhere in your AWS.
Yeah. So in this case, just boot it up on a regular EC2 machine. Then you can set up the credentials. And you can also edit an instance profile if you want to. This is really from scratch, which is what I didn't want to do all of it from scratch,
Yeah,
but we'll have to do it for now. Let's just see if
that's okay.
everything's up and running. Yeah.
So for those who are connecting just right now, we're trying to get a small language model running into a Lambda function. And João provided a very interesting definition of what a small language model is. If you can run it in a Lambda, it's a small language model, and I love that definition. But if you have a different definition, let us know into the chat box.
Yeah, now let's see if this actually works.
So you're now issuing like the sam build command, right? And that sam build, should start.
Docker is running. Yes, yeah, Docker is running. So
Yeah.
it's a good option. As you can see, so we're going to use the Node.js 20 version. Okay. Now response streaming works with Node.js out of the box, and we're also setting up in the Docker build args, so the model name. Actually, while this is running, we can actually check some other definitions in the code. I think it'd be nice to see that.
Yeah.
By the way, the bottleneck for building is actually the model size. So everything else it takes a little bit of time to install the dependencies. It's just
let's go for a tour of the code just to have
of course.
an understanding of what's running behind the scenes.
Let's go. So as I mentioned, there's the template, and as you can see in the template, we're just setting up a single resource or a Lambda function, serverless function. We're going to package the code as an image, as you've seen. For this one, okay, one optimization would be to run this in a Graviton instance, pending to do. So if you want to implement this, I'm happy to receive your pull requests. We're going to attach a specific policy, and it's Lambda execute, because we don't actually need that many permissions to run this. And also, we're not going to connect with GPT-4All. There's that option if you want to, but you're going to run this offline, okay? In a sense, we're not going to connect to any external resources. So everything it needs to run is going to be inside the container. Okay. There are other options, of course. You can also add the model into a Lambda layer. So that's an option you can also use, and you can decouple the function code from that Lambda attachment. You could just switch between the different nodes if you want to.
And just out of curiosity, do you have like a size of that? What's the size of the container, or like the full?
Yeah, so the model size, I have to check, but I think is around 4 or 5 gigabytes or something.
Okay.
And it's mostly just a layer with a model.
Okay. Sounds good. So, so this is the actual container that's going to be run by Lambda as a custom runtime. Sounds good.
Yes, exactly. Interesting things. So we're setting up a function URL config, in this case for response streaming, and also for authentication, which is going to be done through IAM. So if you have credentials, you can just pass them. Otherwise, you won't be able to call this. This is good practice. I've seen some things done with response streaming that they don't actually set this up. This also means that we have to sign the request that we're going to make to the model. And then
so I usually use like a Postman. It has like a kind of a credential input for that. It does like the CV4, or there's
Yeah,
also like I think there's also like an AWS curl or something like that.
yeah, yes. So
Yeah.
there's AWS curl. Curl actually handles that quite well. You don't have to go outside. And in the project, so you go back a little bit. I actually give a few examples on how you can test this.
Ah,
So you can do it locally if you want to. SAM remote invoke and then just call the whole thing, and you can pass the payload. Or you can use curl, and you can also add the AWS CV4, and it's going to sign for the context where you're running this. In this case, for the default region, lambda function, and then pass the credentials and the
awesome.
session
Good.
token.
Okay.
So
So
you don't
so
have to
so
install a lot of things to test this.
okay. Apart from Docker, apparently.
Yeah, yeah, apart from Docker.
So let's
Actually,
load
let's
this
see
up.
if this is running.
Yeah.
Okay, yeah, so we finished the build. No, it's going to give you some information on what to do next. Basically, what you do is deploy this.
Okay, sounds good.
So
Luckily, we
deploy.
didn't have to like specify a dash y or something like that, because that would have been. I always get it. Like it always gets me. Like when I do like a CDK deploy and like there's a dash y to do, and like I always forget. So like maybe I go, I put on a coffee, and then I come back and like nothing has been deployed, and I hate it.
Yeah, try doing that when you're live, and it's even worse.
Mhm.
But yeah, we're going to set up the stack name, the blast region, the default, and then basically we're going to say whether we want to deploy the changes. By default, it's going to say yes. You don't want to disable the rollback, save arguments. SAM config is already inside the project, so you don't have to take any of this. SAM configuration environment, and I think I pasted the credentials. If not, we'll get an error, and you can fix it. Don't worry.
And
Skipping up.
while this deploys, have you run any like cost analysis or like understanding what the cost elements of this architecture is? Because after all, like we're trying to build sort of frugal kind of architectures on top of serverless. Like we want our costs to scale, but only like in direct proportion to how much of this we are using, right?
How this cost is going to scale with the request, you mean?
No,
Is
no.
that it?
So sorry. What I was trying to ask you is, have you done any like cost analysis and understanding like what are the costs involved in running this sort of thing?
Well, the cost dimension for this will be basically the compute you're going to use for this,
Mhm.
and that also depends on the runtime you're going to get. So, well, what I'm doing in the configuration is setting up the timeout to be. I think I'm actually maxing it out to 15 minutes. But then basically it will depend on the size of the answer, right? So if it's running this from cold start, it's going to take a couple of minutes to load the model. But
Mhm.
then if the model is hot, then it's going to take the amount of seconds, hopefully, that it takes to produce the response. So if you
Okay.
have an idea of the average time it takes to generate the response, like the average number of tokens, you can get a sense of how much this is going to cost.
Okay. And then there's also like the data out from the streaming Lambda, right? So those are like the I think the two main components in the costs.
Exactly. Yeah. Yes. Exactly. So it's basically in this case will be the compute required times the compute time is going to take to load the model and run this, and also the storage in this
Yep.
case,
Okay.
and also
Last.
the container is going to be stored on
Uh,
ECR. So you
yeah.
have
So
that.
that's gonna be an ECR, and so you're gonna pay for the storage. But I guess the free tier for that should be pretty generous. So if you're just experimenting, that should be okay.
Yeah. Let me check something because we're not getting. Let's just see if we can run this with a different name. Probably conflict with the end.
Nah, with an existing stack. Ah, damn. Okay, so right now we are redeploying with an acceptable stack name.
Yeah. Let's
Sounds
see
good.
if this works. Yeah, now we're
Okay.
up and running. Yeah, again, this is going to push the image to ECR, and then basically when we create the lambda function, it's going to pull the image and run the whole thing. Okay.
Okay.
Now, when you run this for the first time, it's going to take a couple of minutes. When you run the second time, is a lot faster.
Yeah, yeah. And the reason for that you were saying like it's the cold start of Lambda has to like pull down pull down the container and make it available.
Yeah, so it's not really the pulling the container that takes long. It's actually loading the model into memory,
Okay.
so you can start inference. So that's what takes a little bit longer. Actually pulling the container doesn't take that long.
Mm-hmm. And you use it with your customers to do like small experiments, right? Because if you're able to like get away with running the small language models for like specific tasks, you're gonna save a lot of money down the line, right?
Yeah, so the advantage of this is, well, apart from ECR, which is mostly storage if you're not pulling the
Yeah.
model, you're not actually being billed by for anything if you're not going to use this, and you can just keep it idle. If you want to use this in kind of a dev environment and you want it to be available all the time, then calling it every 5 minutes or so before it goes cold is more than enough, and just one call is just ping it, and
Okay.
then
So
just say, yeah, just output a token and be done with it.
okay, the small POCs, development environments, and like experimenting, like probably like cost optimization. Like you maybe want to start with like large language models, and then if you can scope it down to a small language model, it's probably going to save you a lot of money in the end. That's an interesting use case. Um, so we are waiting now for it to deploy. By the way, chat, if you have any question for João, or if you have run experiments of this sort and you want to let us know, please feel free to do so. I'm super happy to learn from the community. And
Yep. Yeah, for sure. If you have any questions, feel free to ask. I think we can actually show what the function is. So
yeah,
if we pulled the model, we've created an image. I haven't actually shown what's inside.
oh yeah,
Yeah, so this is a simple a Node.js project. I'm not a Node.js developer. I was able to concoct this in a couple of hours of debugging. Starting with the package JSON is just one. We have the GPT-4 all. Feel free to use another version if you don't want to use this one.
and
And
that's
then we
just an
have the actual
SDK, right?
function.
That's just an
Yeah,
SDK.
the JSON file. Yeah,
Okay,
the JSON file with the dependencies. This comes when you initialize a new node project. So that's
sounds
a
good.
standard, pretty standard. And then the actual function, which is just 20 lines of code. Basically, what you're doing is this is well described in documentation actually. But basically, going to do is we're going to load the model. As you can see, we're loading the model outside the actual function. It's going to handle requests, and this is
Mhm.
so we can reuse this between functions. As you can see, we're setting allow download to false, so it doesn't pull the model. We're using the model that's already there. Also setting the model path, configuration file that basically gives information about the model. If you're going to log everything that's going to happen, and then where this is going to run. So in this case, it would be CPU, and you can also set context window, I think. And then basically you're going to do is streamify the response, and then we can pass along the event body, and this is where we're sending the user prompt. Okay? And then you can just add this line to wait for each chunk, and then send a chunk at a time as they come along to the end user,
Okay, sounds
and then you
great.
just have to process them on the user side, and that's it.
Mhm. So that would be an endpoint that you can invoke from your front end application, or if you're building like a CLI or something like that.
Yes,
Okay.
yeah, that's right, that's right.
Shall we just
Uh,
have a look at see if it's been deployed?
yeah. Right now, so we've pushed the image. As you can see, it's going to create just a role, the Lambda URL, and attach it to the function. Let's just deploy this.
Sounds good. So push the okay. And this shouldn't take too much because it's just like very minimal infrastructure. What is going to take a while, you were saying, is if we are like once the infrastructure is deployed and we are
Yep.
actually
So you're going
invoking
to
it.
make one initial request. It's going to take
Mhm.
a little bit of time to load.
Yeah. Is there anything that you have to do to like write the request, or is it like it's just a standard HTTP request with a body?
Yeah, so we can look again at the example actually.
Hmm.
So the only thing we need for this one specifically is to send in a body with a message and the user message. In this case, just explain me the theory of relativity because we're both physicists, and I
Yeah.
just want to do something cool for the demo. But yeah, so the thing you need to do again, this is going to be authenticated via IAM, and you can do that by signing the requests. If you use curl, you can do it like this. If you're doing it locally, you don't have to sign it because it's not supported as far as I know.
Okay. Yeah. Sounds good.
Yeah.
Okay.
Everything else is just passing the credentials, passing security token, and then you can also just need to define what the content type is, and that's it.
Okay. Sounds good. Let's see if it baked. Still
Yeah,
baking.
yeah. So this is running. Let me check what if we were missing anything. Yeah. So the actual well, let's check the Docker file. I think that should be also interesting.
Oh yeah.
Lambda function, Docker file. There are a few changes from the original Docker file that was shown in the blog post, but basically going to use the Lambda image for Node.js, in this case version 20, from the public ECR repo. You can pass in the model name if you want to, and then we set it up as a model name environment variable that will be passed in directly into the function. And then this is used to, in this case, download the model and also the model configuration.
Okay.
Then you just copy our function code and then just run the installation. And that's it. Well, apart from this download phase and this setup, it's pretty standard Lambda function. So
So what, like
nothing new.
a total like less than 40 lines of code, and you have your inference endpoint.
Yes, yes. That's a take home message. I think the package's JSON is actually like 10 lines of code. So in
Nice.
less than 50 lines of code, you have something up and running. It's pretty cool.
That's good.
Most of the files are auto-generated by Sam. And then you just need to add some snippets in the configuration, and that's it. So yeah, so we already have the Lambda function URL. We have the role that is being used to in this case, yeah, this is the role that is going to be attached to Lambda function, and then the Lambda function or ARN, in case you want to check it out. So yeah, so this is our function. Let's just copy this, and we had the snippet of code. Let's just see if we can actually test this out. Again, this is going to take a little while to get started. So it's a function URL. Yeah, function URL. So what you're going to do is export the function URL as an environment variable, so you
Again,
can use
can
it.
I just ask you to like zoom in a little
Yeah,
bit?
of course, of course, of course. Just remind me, because
Yeah, yeah,
otherwise I'm just
yeah.
going to forget this.
Of course.
Uh, yeah, so what are you going to do? We should already have the credentials, actually. What we're going to do is run this curl command. Hopefully curl is installed. Yeah, of course, because I haven't defined the default region. So in this case, I'm using the non-standard AWS default region to set this
Mm.
up. So we also need to set that up.
And you do it like exporting, right? So export the
Yeah,
name of the variable. Like,
yeah,
yeah.
yeah. Just set up. Yeah, we just need to set up the the I've done this because I wanted to decouple the region where Sam is running the instance from the region where the Lambda function is going to run, so we can have this.
Yeah. Makes
So yeah,
sense.
so now it should work. But let's see if it does. So this is going to take a while to run, but maybe you can just open the Lambda console and check.
Yeah. Let's have a look at
Check
the
this.
logs, maybe.
Yeah, let me just open the Lambda console. Yeah, and let's see this up and running. Now this was tested with some. Actually, I think this is running actually the small model version, because there well, again, even within the small models family, there are models of even smaller size, and you can. In this case, we're running an even smaller model than the one was used for the blog post, just to speed things up. So it should be Slumda demo, I think. Yeah, here it is. Again, this is going to run directly from the image, so you're not going to see the function code,
Hmm.
but you can see the image URI. So
Yep.
if you need to this is it's easy enough to do. If you check the monitor, we should see actually a call to the function. Yeah, we can see that call over there, and we can check the logs. Let's see if this is still running. Yeah, it's still running.
Yeah. I guess the reason is the cold start that we described before, right? So it's gonna take a while.
Yes. It's going to take a while, but while this is running, we can actually test some, show some other things, and then we can go back and see that
Yeah.
this is actually running.
Once.
It's a good sign that it's not breaking, and I'm
Yes.
glad that we just stumbled into some dependencies.
I mean, it
Uh,
takes a lot of courage to run a live demo from
I,
scratch.
I'm just dumb for doing it, but yes, you
I'm
can call
not.
it courage if you want to.
I'm not gonna do it. I have a lot of stuff in store, but like it's already deployed. It's
Let's
there.
just see if we can find where it's actually loading the model, just to show that it is loading the model. Okay. Okay. Let's just check this.
There
It
it
should
is.
be this one. Yeah. So as you can see, we are, yeah. So it's getting the information from the model. So in this case, how much RAM is required, the number of parameters, the type of quantization, and type of type of model. So it's actually running the Falcon model still. We haven't changed that. Now it's going to take a little while, and as you can see, it's running this multiple times. So it's going to while it is loading, it will keep on loading. It
Hmm.
may fail the first time. Okay, it really depends on the compute that is allocated, and then once you run this one a couple of times, it's going to run, and you can make the requests. Okay, so while this is running, I think we can check other
Okay.
projects.
Yeah, sounds good. Let's move forward, and then we're gonna come and have a look at this while it's baked. So if everything goes all right, you will see how you can actually, with less than 50 lines of code, I guess, you can deploy a small language model onto Lambda. So really powerful, especially from the perspective of like testing environments, development environments, or even just like doing your small POCs and prototypes. But I guess the next one we wanted to talk
Is a
about
little bit
is
different. Yeah,
yeah,
it's a
yeah.
little bit different. Yeah. So in this case, it's really about, well, yeah. So sometimes small language models are not the best option. What can we do on AWS that won't break the bank? Okay, and how can we integrate that with open source software, namely LangChain? Okay, and what I want to show you is how you can do basically the one-click deployment. Not actually going to do the one-click deployment because it takes like 10 minutes, but you can actually run this locally and show that it is working. Okay. But yeah, so the idea is to use LangServe. I don't know how many of you have heard about LangServe. Basically, LangChain is kind of an ecosystem. We have, yeah, LangChain proper. We have satellite packages like LangChain AWS that you can use to connect with models within Bedrock, SageMaker, and different databases vector databases that you can run on AWS. We have LangServe that's basically going to create a RESTful API around your chains. We have LangSmith for monitoring, and we have LangGraph for basically cycles within your chains. So there are a lot of things. So, but this one is mostly covering three of this pack. It's going to use LangChain to create the actual chain, and then going to use LangServe for serving. And optionally, if you want to, there's a section on it how you can monitor the whole thing with LangSmith. There are other options, but at the time I was using that one.
And when you
Uh,
say chain, like
yes.
can you give it less like an overview what you mean by chain? Like, is it a thought chain? Is it like the way you define the application?
Yes. So basically, a chain is a way to specify how information is going to flow between models and databases and functions, and really how you get from a user prompt, something else, into the end product. Okay, which can be whatever you want to actually. And LangChain, and specifically, one thing they're going to see in practice in terms of implementation, you can actually just pipe literally pipe different blocks within LangChain so we can pass the messages along. Maybe we can actually show this in action. So there are two options for this one. We can go for the fast lane, basically deploy a project that already exists. We can go for where is it? I think I had actually explanation of the different options. Yeah, so we have the fast lane and we have the deep dive. I'm going to show the end result of a fast lane if you want to. Basically, we have, this is the project. Okay, we're going to go over the code in a second, but basically once you deploy this, I'm going to use, well, we use AWS Copilot in the blog. You can run this with one click on AWS ECS, Amazon ECS and Fargate, and then basically you get something like this, okay, without adding anything else to your code. Which is kind of nice, like a fast API environment. And all of this was automatically created by LangServe. Okay. And then the idea is that you can just, well, LangServe also offers you something called a playground. I think it's Claude Chat Playground. Yeah, exactly. Playground. And then we can do something like select the model we want to run this on. We can specify a role. Let's go for Mickey Mouse. And then just ask something like, what do you want to do tonight? So basically what you're doing is doing role prompting. So we're assigning a role to the language model. Let's say, you're Mickey Mouse, act like it, and then asking a question. So it's going to be injected into the prompt template, which specifies basically the format of your prompt. And then you're going to hopefully see the output. Yeah.
Yeah.
Oh boy.
And
Yes, that whole boy is clearly Mickey Mouse. Yeah.
can you just like maybe double click on like the architecture of this and how it looks
Yeah.
like?
Yeah, of course, of course. Let me check where that is, because
And
I
by the
know I
way,
had.
I've shared the link into the chat, so you can go and have a look at the actual article that we're discussing right now.
Yeah, so I think the architecture is down below, or if not, we could just check it from here.
Yeah.
So yeah, so this is the architecture that we have. I'll just open this in a bigger
Yeah.
screen. So what we do with AWS Copilot is that we add a little bit of buffer, like manifest file, similar to what you have with Kubernetes, but basically on a higher level. And then you specify the different services you're going to deploy. We have only one service, which is called Bedrock Chat or Claude Chat, and then this will be the container. This is going to run the LangServe. Okay? And then you just have an application browser in the front to redirect all of this. The container is going to call Amazon Bedrock. In this case, we're restricting, and I'm going to show you how to do that, restricting only to cloud models.
Okay. And so this is a way to basically speed up your deployments to production for this sort of applications. Okay.
Yeah,
So,
this is a sort of a micro pattern for a
mhm.
backend or something of the sort. Well, this is publicly available, but you can set it up as private and then add other services for the front end if you want to, or just expose this with authentication. I don't know if you noticed that one, but if you go one back, we can actually have a basic authentication setup.
Okay. And this is running Bedrock, but if I had any like any
Yeah.
other large language model, could I do a deployment on top of those?
Yes, yes. So you can also do that if you want to. Again, this is not specific to LangChain. AWS Copilot is agnostic to what you're going to
Hmm.
run. The only thing you need to make sure is that the manifest is set up correctly. But let's actually look into the code to see how this is
Yeah,
organized.
sounds good.
So let me just close all of this. This is just clutter for now. Just look into the organization for this. So basically, this is a project we have available on GitHub. There's an environment, and this is basically, if you're going to follow the deep dive, you can use this to set up a Conda environment from scratch on your own local station if you want to. Then the infra as the CloudFormation template that you can use to set up an environment similar to this one I'm working on. This is not from scratch, so they'll have everything you need to run this. And then if you go to Bedrock Chat app, this is where the magic actually happens. Okay, so let me just close this a little bit so you don't have be overwhelmed by this. So basically, have two things to keep in mind. So LangChain and specifically LangChain CLI, which is what you're using to bootstrap the project, is going to use Poetry. So you need to update the dependencies, add things like Boto3, the LangChain AWS package in order to run this. And then we have our actual app. In this case, it's just a server file. And if you open this, as you can see, it's just fast API. Okay, there's no LangChain reference at all. Okay, so basically setting up a fast API called Claude Chat with the router with some basic authentication, which is just username and password, and this is coming from parameter store. And then you basically add this one, which is the one you're going to use to make sure that the container is actually running. So this is not authenticated; it's just a way to ping the container. And then we have things like the home endpoint, docs, redoc, and the OpenAPI JSON, which is going to be generated automatically by LangChain. Okay, and then we just kickstart all of this. So this is the standard fast API file, and this is the one that's going to run inside a container. Now, for the actual package, this is where we install different services. So in this case, we have just one, but you can add as many as you want to. Okay, we have one called Claude Chat. Again, this is going to call different Claude models. And then if you open, you can go actually for chain. We can see the different steps. So this is not the standard organization you'll see in a Python file, but this is the one we followed in the blog post. So just to be more strategic about the things we're integrating. And it also is a good introduction to the way LangChain integrates with AWS. So basically the first thing we're defining is a set of model parameters. Okay, these are common within the Claude family, things like the temperature to control the randomness of your response, top P and top K to control the sampling of the response you're going to get. So it's going to generate multiple responses, and we can sample from those. And also the length of the response we're going to get in terms of the number of tokens. Okay. As you can see, we're also setting some default values, but you can change that by using different parameters in parameter store. Then, and this is important, so we have a separate package, satellite package, only for AWS. And as you can see, we're pulling the chat bedrock, and this is the one you're going to use to specify the different models that we have available. So you have things like the Claude 3.5 Sonnet, we have Opus, Haiku, we have the older versions, Claude Instant, and we are injecting the different model quarks and doing it this way. As you can see, it's just a dictionary with the names for the model, which is the thing is going to show up in the playground, for instance. This way, we can specify different options for the model. And then we actually initialize the model. Okay. Now, this you can think of it as a box we're going to send our messages. Now we need to send some message. So what does the message actually look like? So we're sending a system message, and this is where we assign the user role, the role, sorry, for the model. In this case, you are Mickey Mouse, right? And then we pass the human input. Okay, and in your examples, what are you going to do tonight? And this is going to basically create a prompt that's going to be injected into the model. How do you do that in an easy way? You can just pipe it through. Okay, this is called the LangChain expression language, and it's an easy way to specify really complex chains without basically adding a lot of boilerplate code. You just initialize the model, the prompt, everything you need to run this, and then you just pipe them through and pass the message along. Okay, and that's it. That's it. Once you
Sounds
install, yes, you add this as a dependency, add everything you need to run this. Again, Boto 3, LangChain AWS. It already creates a Docker file for you. You're free to change it, of course. But the idea is that it's just going to copy all of these files, and then it's going to basically run the fast API via UVcorn and expose that on port 8080. And that's the one you're going to look into. Okay.
all right.
So
Sounds great.
that's the application. That's the
Yeah.
application.
Yeah, that's fantastic. So basically, this is a way that you can just start with like for prototyping an application with that interfaces with Bedrock right now, and it's just like
Yeah,
one CLI line of code to just like get it up and running.
yeah. So
And then,
the buffer of it is actually creating the server .py, what the code is actually going to run, and the chains, the different chains. And this is only for development, but next you have to deploy all of this, and then you have to define some additional files. Again, the manifests, which specify things like the environment you're going to run this on. And as you can see, we can specify. We can be simple about it. Just specify the name and type of environment, and we can do more complex things. In our case, the architecture that you saw is for what is called a load balance web service. Okay, call it Claude Chat, and we basically do where first we're going to send requests. What is the path we're going to use to check if the container is up and running? How are we building the container, and what port is going to be exposed for all of this? You can also specify things like CPU, memory, how many containers are going to run with this. You can specify variables. You can add secrets. All of this is specified in the blog, and you can also restrict things. So you can use something called an add-on policy. In this case, it's only for Bedrock. But what we're doing is, where is it? Restricting invoke model and invoke model response stream only to the Anthropic provided models.
Sounds great. So if you want to get started with this, I've posted the link in the chat, so you can go and see the article that João has published. Let's have a look. Let's have a look if this actually
Yes.
if it
Yes.
actually works.
Yeah, so as you can see, it generated an output. Let's just move this and clean it a little bit, otherwise we won't be able to see a thing.
Yeah,
So if you run this again, hopefully it didn't take too long to explain. You can see it,
there
the
it is.
tokens are coming one at a time, okay? And as you saw, it didn't take as long as it did the first time. And
So
we've been
this,
speaking for like 20 minutes, so you don't, there's, it really depends on the setup that you do for the Lambda function. But as you can see, well, apart from some some shenanigans with the dependency, it's quite easy to deploy something
yeah.
like
So
this.
basically, this is a like an inference running on top of a Lambda function, making use of small language models, and it's probably going to cost us very like it's going to be really cost effective, because the only thing that's running here is a Lambda, a container hosted on Lambda.
Yeah, so there's a lot of margin for something like this.
Mm-hmm.
Okay, again, we were using a Falcon, which is actually one of the biggest, smallest models that we have on GPT for all. We're using a specific model format, GGUF. Maybe there's another model format that is coming in the next few weeks. So this is something you can also bring here. Again, the limitation, in my opinion, will be mostly around the software, if it is compatible or not with Node. So if you design something like this, it'll be compatible with response streaming. But if you don't require real-time answers, then you can certainly do this in any kind of language.
Oh yeah, so this you could also see. You can also use this as like a batch
Yeah,
sort of
yeah, of
program.
course,
Yeah, that'd be
of course, of
fantastic.
course.
Right. So, Joe, thank you so much for these two examples. I wanted to jump into the last one. So, this is when the we can have large language models actually running through Bedrock, but we have worked on a um, we worked on an experiment called full stack serverless retrieval augmented generation on AWS. So I'll just gonna swap onto this, and we're going to discuss a little bit about, in general, what retrieval augmented generation is. It's basically a technique that helps us retrieving information from external databases, and using a little bit of prompt engineering. It's going to inject all of these relevant informations into the prompt that is going to be presented to the LLM, and fundamentally, it's influencing the generation of the LLM, so that it's a technique to limit hallucinations. Let's put it this way, on for an LLM. But it's also a way that customers can actually use their own private data, and their own private knowledge to actually influence the response of an LLM. In particular, in this architecture, we have been focusing only on actually using completely serverless components. So nothing here is running. It's running 24/7. It's only running when we actually want. And we're using an interesting open source project called LanceDB, which is a multimodal vector database for AI applications that, believe it or not, uses S3 as the backend for its data. So fundamentally, your knowledge base for your LLM is not going to run 24/7. It's only going to run whenever you actually need it. And I have a small demo here. And I'm not gonna deploy it from scratch because it's gonna take like 30 minutes or so. And by the way, I've also have like this article if you want to learn a little bit more about it. Actually, yeah, there it is. I'm sending the link to I'm sending a link to the chat box right now, but let's have a look. So right now, I'll just show you that I do not have any documents in my knowledge base, and I'm going to ask this question to Claude 3. And I'm asking about what is Amazon Drone Fleet. Amazon Drone Fleet is a service that does not exist, that I have invented. And we're going to ask this question. And hopefully everything is going to work fine. So here it's saying, hey, unfortunately, I do not have enough context to get you like a factual information. And this is how we have instructed our application to reply. Let's go and upload a document. And again, I'm keeping my fingers crossed because the demo gods should be on our side today. So let's have a look. It should be uploading. It has uploaded. It should be, there it is. I started ingested. It finished ingesting. So what is happening right now? This document has been uploaded to S3. It's been set on an SQS queue. There's a Lambda function that is a loader. So basically, what the loader actually is doing is creating embeddings for the document that has been uploaded and storing them into our LanceDB bucket, which is the bucket where we are storing the embeddings. And also we are using a DynamoDB table just for the metadata of the document, and also to make sure that we are not uploading the same document many times. So it's basically just let's say a cache to make sure that the user is not uploading many times the same document, and we're not paying for embeddings that we're not actually using, because it's going to be the same. So finish the processing. We are going to ask again the question. Hopefully, again, demo gods, please. There you go. So we have a good representation of what it is. We are also actually able to go and see what is the documentation that we have brought on from the perspective of the retrieval augmented generation. So this is data that is actually stored only on S3. The other thing that I wanted to show you before we actually have to go is the fact that in this particular installation, we have a dynamic prompt management. So this is the prompt that is actually that we're actually using onto the Lambda function within the LangChain application. So you have a prompt header in which we are asking the LLM to answer this question with some sort of like markdown. Please do not use images and stuff like that. And then if some context is found, then it's going to use the context footer that you see here. So the context footer for this is base your answer only on the context that has been provided. And here's where the context is. And in case there is no context, so no documents were retrieved, so this is where you actually can say to the LLM, hey, we didn't find any sort of context, so please advise the user to actually upload some documents. And this was like our initial end-to-end user experience, right? The other thing that you can actually do, and I love doing this, is like from this UI, it's actually you can actually override parts of this prompt. So, for example, now I want the LLM to answer as an annoyed teenager, because I just love that. And let's see if this actually works. Like, we're gonna use Sonnet. I've seen Sonnet sometimes refusing to actually. Oh, it's actually gone. So roles, do I really have to explain this to you? Amazon drones for this, blah, blah, blah. Okay. So yeah, so I'm going to send you a couple of links to this open source project. It's available on AWS, AWS samples. This is the article on community, and this is the repository. Feel free to have a look. I know that we have a question coming from the chat, so I'll just bring it up. Let's have a look. Just one question: is the LLM running in Bedrock, running in privately in my VPC? Okay, so in terms of where is the LLM running, Bedrock, the Bedrock service is actually running the model for you, but it has nothing to do with the provider of the model. So fundamentally, what happens is that we have dedicated environments in which the LLMs are running, and there's no communication with the provider. So AWS is actually running it on your behalf. It's not in your VPC, but what you can do to have the communication only going from your VPC to the Bedrock service is actually using a VPC endpoint. So you're sure that from a regulatory perspective, you're sure that the communication is only running over the AWS backbone. So that's how I would architect that. And sorry, I'm just trying to understand the rest of the question. Running in Bedrock, running privately, or just an API call to model hosted at a common place. Yeah. So basically, so if you're not running if you're running Bedrock on demand, this is going to be hosted on a specific environment, but it will be an environment that is managed by AWS. And oh, damn, apologies, I have to end the stream right now because we run at the top of the hour. But hopefully this was interesting for you, João. Thank you so much for joining us today.
Thank you so much for having me.
Absolutely, it was an absolute pleasure, and thank you so much, folks, for joining us. You have all of the links, but if you have any additional questions, we will be happy to answer them through LinkedIn. And yeah, thank you so much. Hopefully, we'll see you again in the next session soon. Bye bye.
See you next time.